Hi, see you guys again. Welcome to my channel. This is the third video related to how arrays are implemented in JavaScript. I will use V8 as an example. Inside the V8, each array are marked as an element kind. I already show you guys 7, right? Which are parked semi-elements, parked double elements, parked elements, wholly semi-elements, wholly double elements, and wholly elements. And last one is for the slowest array, which is a dictionary elements when you have lots of holes, right? I already explained. Watch my previous video, okay? And inside of JavaScript, for the numbers, it actually have two kinds of numbers. One is a semi, which is it's called a semi, small integers, okay? The other one is a heap numbers. Here I show you a briefly example here. So here we have an object. Here we have an object here. An object has two properties, one x and y. And for the value 42, this is a small, which is semi. And for 4.2, this is a heap number. It's a double or floating, okay? And in JavaScript, in V8, when it store for the small integers, it will store with the object itself. Okay, this object is in heap already. Okay, it will store with object itself. But for this y property, which is the heap number, which is double. Okay, here double. It will have another object being created inside the heap, and it will using a pointer to point here. So every time when we access o.x, it will directly grab from the object itself, 42. But every time when we trying to using o.y to get a 4.2, it will through the object, and the object will have a pointer and then grab the value to here. So you kind of like have an extra step, and also you have one object being stored in the memory. And the things gonna happen in next step is supposed like this way. I will increase x value in 10, and it will directly make the changes inside the object itself. But if now I want to increase for the y, what's gonna happen? And due to the immutable reason, okay, immutable, because 4.2, this is immutable value. And what's gonna happen? In the memory, I will create another heap number, and then are added as 4.2. Now add one, right? Add one, okay? 4.2, and then make the point to the new heap number. And for the old one, eventually gonna be garbage collected, and that's a step. And think about it. Suppose I have a loop, keep adding the values on the y, this one, okay? I loop 5 times and add each time add increase 1 on the y, and think about how many objects being created in the heap. Okay, that's why when we have a semi, okay, and like a semi numbers, which is small integers, the performance is gonna be faster than the double and the other numbers, the doubles, and also faster compared with like a string values and other values. Okay, that is the thing, the first part about a semi and heap numbers. Heap numbers you can think as a double. Okay, next example I want. If you for this type, V8 still do the tuning, and how they do the tuning, you look at it by yourself. Okay, I don't want to go deeper on that part. And for the packed and wholly optimization, and think about, if you are a developer, think about this case, okay? I create an array 1, 2, 3, which is the length is 3, and the index is 0, 1, 2, and now I directly add 5 on the index 10. So now my array gonna be look like what? 1, 2, 3, and then 4, 5, 6, 7, 8, 9, 10 is 5. So for between them, between the 3 and the 5, which is between index 2 and index 10, this one, all of them are holes, which is empty, right? Empty items. And total we have 1, 2, 3, 4, 5, 6, okay? And this is index, our other index here, okay? Index, let me use another color. Green. This is index 0, this is index 1, this is index 2, index 3, index 4, index 5, index 6, index 7, index 8. Oh, I'm missing one. This one index 10. Okay, I'm missing one. This one should have another one, index 9. Okay, let me add another one. Okay, here have index 9, and all of them are holes, right? So let me use another color. Okay, blue. Okay, now I want to print ARR8. This 8 index, I want to print the value which is represented on the index 8. So if you are a developer, what's gonna happen? Based on the ECMAScript specification, we have to give what? We have to give an undefined. The value we want to get is undefined. Okay, the value we want to get is undefined. But as a developer, okay, if you implement V8, what you will do? Okay, so you're gonna do the checkings. Okay, first we'll check the length, which index AR8 is greater than 0. Okay, and then 8 is less than the array length. Otherwise, it's the boundary check, right? If it's returned true, then we can continue. If not belongs to, then we can directly give the undefined, right? Couldn't define, because it's the boundary. It's beyond the boundary. And next one. If it returns true, we cannot directly give undefined. We cannot directly give undefined. The reason is what? The reason is, is this really undefined, or it's because of the hole? We have to do more checkings to make sure we actually can return a defined here. We have to check that it has own properties of 8, because you may have an all property of 8, okay, which is the key is the 8 you may have. And if it return false, we have to also check the parent, because an object, the parent of object is array data prototype. This one you guys probably not familiar. We will talk about the inheritance, and you will see this one. Okay. Anyway, this is the parent of the array, which is this AR. We have to check, do we have an property? The property name is 8, and do we have? And if it return false, we have to continue checking till object. Object is the top level of the hierarchy tree, which is the inheritance hierarchy tree. And do we have? And if not, we return false. Eventually, if all of them return false, then we can show, okay, this is a whole. Then we can directly return undefined. Otherwise, you cannot from here, you directly return undefined. You have to do more checkings here to make sure it is a whole, then you return undefined. But if it's not a wholly elements, or it's not a wholly something, okay, semi or wholly double, like this way. I have an array, and I have the array length is 3, and I have one undefined 3. No, sorry. What I'm doing? I did the type. I did the. I want to. Let me just do like this way. I did what I did. Okay. Okay, like this way. Okay. Wait a minute for a second. Sorry for that. Next one. If I have a packed array, this one we know is what thing? Packed elements, right? Not a wholly, it has no hole here. Now I want to access array 1. Okay, we know it's a packed. Okay, so we just check array 1, and this one is for boundary check. And we say, okay, it's inside boundary. And since it's packed, the value surely exists. Because we know if it's undefined, we know it's undefined, okay? If it's something else, we know it's something else. Because it's packed, no holes at all. then you can just return whatever you find in the memory, right? And we just return undefined in this case. But if we have a hole, we have to do more checkings to make sure we can return undefined safely. Okay, and that is related to packed and wholly optimization, because when we do wholly, we have to do more checkings. That's gonna slow down the performance. Okay, I think that's two examples. It has many other. It has many. It also have some things I didn't cover. Okay, I just gave two brief, which is easy understand example here to show you how those element kind affect performance inside the V8. Okay, that's it for the video. Thank you for watching. See you next time. Bye bye.